Okay, students. So we were dealing with some of the important graphs and their functions, or some of the important functions and their graphs. In that, our last function is greatest integer function. Very important function, very beautiful function if you understand it. If you don't understand, then this function is going to eat your everything in your brain. Clear? So first let us define this function. Clear? F from R to R, that means real numbers to real numbers, is defined by f of x equal to greatest integer of x. It is written in square brackets for every x belongs to R, that is in domain. Assumes the greatest integer lesser than or equal to x. Lesser than or equal to x. Lesser than or equal to x is very important. See, f from R to R, a function defined from f from R to R, defined by f of x equal to square bracket x for every x belongs to R, assumes the greatest integer lesser than or equal to x. Assumes the greatest integer lesser than or equal to x. This you have to understand. Clear? Assumes the greatest integer lesser than or equal to x is called greatest integer function, that is GIF. Clear? Greatest integer function. Okay. So f from R to R defined by f of x equal to square bracket x for every x belongs to R assumes that greatest integer lesser than or equal to x is called greatest integer function. Okay. What is meaning of this? See here. I will draw a number line. Here I will take 0. Here I will take 1. And here I will take -1. From this, a small example of your number line from -infinity to positive infinity. See, this is called a real number line that includes all integers, all fractions, all irrationals, or all naturals, all integers, and all type of real numbers. Clear? That is rational and irrational. So this is going to be the union of rational and irrational. Clear? So from this I am choosing a small part. That is from -1 to +1. -1 to +1, just to make you understand what is greatest integer function. Clear? Suppose if I take some value which is greater than 0 and lesser than 1, you consider it as 0.2. Are you getting my point? You consider it as 0.2. So this 0.2 is in between 0 to 1 on the number line. It is in between 0 to 1 on the number line. Now I want to find f of 0.2, that is greatest integer of 0.2. Greatest integer of 0.2. What we have to think, where this 0.2 lies? 0.2 lies in between 0 and 1. Clear? What greatest integer function tells? Assumes the greatest integer lesser than or equal to x. See here, what is x value? 0.2. What is your greatest integer? Lesser than or equal to x. Lesser than or equal to this x value. That means the greatest integer which is lesser than or equal to 0.2. Because 0.2 is not integer. Are you getting my point? 0.2 is not integer. So for this term, which integer you have to consider which is lesser than or equal to 0.2. Are you getting my point? So the integer which is lesser than or equal to 0.2 is what? See this, 0. Clear? That means greatest integer means what? They will give you one number of the kind 0.2. They will ask you greatest integer. In that condition, what you have to do? You have to check the greatest integer which is lesser than that given number. Which is lesser than that given number. That means in all real numbers, which one is the greatest integer which is lesser than 0.2? Are you clear? That is called greatest integer of 0.2. In all real numbers which are lesser than 0.2, in that which is greatest, that is called greatest integer of 0.2. Are you clear? So if you check those numbers, if you see the lesser numbers than 0.2, these all numbers will be including, but in that which is the greatest integer, 0 is the greatest integer. After 0 you will get -1, after -1 you will get -2, but among all those 0 is the greatest one. Are you clear? So 0 will be the output of this greatest integer 0.2. Clear? Again, you choose any number. Now you choose 0.3. Now again you have to think the lesser than 0.3. That real number should be lesser than 0.3 and that should be the greatest among lesser than 0.3. Again you are going to get 0. Are you getting my point? Because lesser than 0.3 among those lesser numbers, which is the greatest integer? That is nothing but 0. You take 0.4, for that also 0. You take 0.5, for that also 0. You take 0.999, for that also 0. Are you getting my point? Because what greatest integer function tells? Whenever you can take 0.99999 and calculate greatest integer. If they are calculating the greatest, see, approximately equal to, that is different. This is approximately equal to 1, but I am not asking approximately equal to. I am asking greatest integer value of 0.99999. There is a difference between approximate value and greatest integer value. What greatest integer value tells? Greatest integer value tells that is the greatest integer which is lesser than the given number. For example, 0.9999 is given, lesser than that, in that lesser real numbers, which one is the greatest integer? See, 0.999 comes here. Okay. So lesser than this means you have to go left hand side. You have to go towards 0. You have to go towards 0. You have to go towards negative infinity. While coming to the negative infinity, which one is the greatest integer? That is 0. Because there is no other greatest integer lesser than 0.999 which is greater than 0. Is there any greater than 0 integer in between 0 and 9999? That means 0.999? No. Because 0 is the only greatest integer for 0.99999. Okay. So that's why the output of this will be also equal to 0. Are you clear? So whenever, what we say for greatest integer, whenever x lies in between 0 and 1, whenever x lies in between 0 and 1, the greatest integer of x will be always, that is f of x, greatest integer x will be always equal to 0. Approximate value is different, greatest integer value is different. Please don't get confused. Okay. On the same way, now you can say, if the x lies in between -1 and this term, -1 and this term, what is the greatest integer? If x lies in between -1 and 0, x lies in between -1 and 0, f of x, which is x greatest integer, will be equal to what? The numbers here lesser than that, among that lesser than real numbers, that means the numbers in between -1 to 0, lesser than that, among the lesser than that real numbers, which one is the greatest integer? -1. So -1 will be the greatest integer if x lies in between -1 to 0. Are you clear? So if you don't understand, you think a simple term, or if you understand the simple term, if x lies in between 2 and 3, if x lies in between 2 and 3, the greatest integer will be 2. The greatest integer will be 2, not 3. Are you getting my point? So many students get confused. They write 3 because greatest makes them to get confused. But greatest meaning is here. Clear? It assumes the greatest integer lesser than the given number. Okay, that's what the important. So whenever x is in between 2 and 3, the greatest integer will be 2. Whenever x is in between 3 and 4, the greatest integer will be 3. Whenever x is in between -3 and -2, -3 and -2, -3 will be the greatest integer. Are you clear? So these things you must understand in the greatest integer function. We shall draw the graph and we shall see what will be the nature of graph of the greatest integer function. Clear? So but first you understand that function and take some examples like x is in between 9 and 10, x is in between -9 and, so here you just check what will be the greatest integer in between 9 to 10 and -9 to -8. Clear? Now I will draw the graph of this particular function, greatest integer function. That is, see the graph, that is y-axis, this is x-axis. Clear? Y-axis and x-axis. So for 1, 2, 3, 4, just I will take a simple examples 1, 2, 3, 4 and 5, -1, -2, -3, -4, and here you may get -5. 1, 2, 3, 4, 5, -1, -2, -3, -4, and this is -5. So now if I choose any term in between 0 to 1, if I choose any term in between 0 to 1, where is your graph? Your graph will be on 0. Your graph will be on 0. Are you clear? I will choose each and every term. I will choose each and every term in between 0 to 1 for all the terms in between 0 to 1. For all the terms in between 0 to 1, the term will get at 0. For, see this is for x in between 0 to 1. here 1 is not included. In this interval 1 is not included because the greatest integer of 1 will be 1 itself. The greatest integer of 0 will be equal to 0 itself. The greatest integer of any any integer will be that number itself. You can take f of 2. Greatest integer of f of 2 will be what? 2. If you put any integer in this function, the same thing will be the output. That's why while drawing the graph or while defining the definition, what we say, which is included with 0 but not with 1. That means we are taking every number in between 0 to 1 where 0 is included but 1 is not included. Are you clear? Next, x in between 1 to 2. X in between 1 to 2. That means I choose every number. In between 1 to 2. For that all the outputs will come and gather at 1. For all the numbers in between 1 to 2, all the numbers come and gather at 1. Are you clear? On the y-axis. Are you getting my point? Clear? Next, whenever x is in between 2 to 3, same again. All the numbers will gather at 2. Whenever x is in between 3 to 4, all the numbers will gather at 3. Clear? Whenever x is in between 0 to minus 1, whenever x is in between 0 to minus 1, all the numbers will come and gather at minus 1. Whenever x is in between minus 2 and minus 1, all the numbers come and gather at minus 2. X is in between minus 3 and minus 2. All the numbers will come and gather at minus 3. So like this, the stepwise graph is formed. Clear? Like this, stepwise graph is formed for the greatest integer function. Please remember this bubble. Where there is a bubble, there is your output. For all the numbers here, where there is a bubble, there is your output. No any other numbers. That means in between minus 3 and 2, your output will be minus 3. In between minus 2 and minus 1, your output will be minus 2. As we discussed here, f of minus 2, greatest integer of minus 2 will be minus 2 itself. F of minus 3, greatest integer of minus 3 will be minus 3 itself. But whenever the numbers lie in between two integers, which one is the lesser integer than that will go there. Okay, see here, if x lies in between 3 and 4, output will be 3. If x lies in between 2 and 3, output will be 2. If x lies in between 1 and 2, output will be 1. Are you clear? So this is how we define the greatest integer function. So please understand this, very very important. Clear? Okay, so please remember the graph, please remember the definition. Next, domain is what? Real number set. Here the domain is real number set. Domain is R, that is real number set. Next, codomain. It is defined from R to R. So this is codomain. Codomain is also real number set. Clear? What is range? Range will be equal to integers. Clear? This is important because say for every number the output is integer. For every real number, the outputs are only integers, no any other numbers. Clear? So that's why please remember this. The range is integer set. Range is integer set. You can see here for all inputs the outputs are only integers. The outputs are only integers. No other number can be possible for greatest integer function. Other than integers, no outputs are possible. So that's why range will be integer. You can see here also we have discussed so many problems in that the outputs are only integers. The outputs are only integers. Clear? Okay. Please remember three things: definition, graph, domain, codomain, range. Are you getting my point? Definition, graph, domain, codomain, range. With this graph, you should write these things. You draw this graph, by the side you write these things. Clear? Whenever x is in between 0 to 1, whenever x is in between 0 to 2, sorry 1 to 2, 2 to 3, 3 to 4. Minus 1 to 0, minus 2 to minus 1, minus 3 to minus 2. These things has to be written with the graph. Are you getting my point? And with after that graph, write domain, codomain and range. The domain and codomain are real number set and the range is integers. Clear? These three things are very, very important. Okay? No problem. You take down it.